This video is about the pre-skin nodes in Unreal Engine materials. I'm gonna explain what they are, what they're used for, and how we can use them. So let's do it. You can download the project file of this video on my Patreon. The link is in the description. Right-click in the material graph and search for pre-skinned. 3 results will pop up: pre-skinned local bounds, pre-skinned normal, and pre-skinned position. Let's add all of them. Notice that when we add them, they all have local in their name. They have no inputs and no settings in the details tab. We can use this section to add a comment to the nodes. All the nodes have it. We can also right-click on the nodes and add the comment here. So what do? Skinning involves attaching the model's surface or mesh to the rig so that it deforms properly when the rig moves. We can use these nodes to create new UVs suitable for world-aligned textures that also move with the character. By using these nodes, we can add effects to our characters before the animation has been applied. That's why they are named pre-skinned. Their primary use is with skeletal meshes, but they also output local info for static meshes. Let's go over them one by one to see what we can do with them. This node outputs a 3-channel vector value representing the local surface normal for skeletal and static meshes. It only works with vertex shader. That's why it outputs an error when we connect it to the pixel shader inputs. In order to use it with pixel shader, we should use the vertex interpolator node after it. If you wanna know the difference between pixel shader and vertex shader, I've explained it briefly in this video. Let's apply the material and assign it to this cube. As you can see, it's like the normal nodes in local space. Watch the vertex and pixel normal videos to better understand how normal data works. For skeletal meshes, this node gives access to the default pose position data. It's great for masking different directions of a character: front or back, left or right, top or bottom. This is a comparison of masking the B channel in both cases. The pre-skinned mask is applied to the character before the animation, but the vertex normal mask is applied after the animation. That's why pre-skinned nodes are better for animated characters. Here's before and after using pre-skinned local normal node with triplanar material. When used with static meshes, it enables us to achieve locally aligned triplanar materials and mesh-aligned effects in our materials. I used these nodes to make the world-aligned nodes work in local space. Watch this video to learn how to do it. If I hover the mouse on top of the node, we can see that it says this node is not compatible with the GPU skin cache feature, so keep that in mind when using it. Next, I'll go over the pre-skin local position node, but before getting to that, make sure to like this video and subscribe to the channel. Also join our communities on Telegram, Discord and Facebook. You can ask questions or answer them, share your work in progress and more. If you're interested in supporting the channel and downloading the project file of this video, check out my Patreon. The links are in the description. This node outputs the local position for skeletal and static meshes. It only works with vertex shader, so in order to use it with pixel shader, just like the previous node, we should use the vertex interpolator node after it. Apply the material. As you can see, it's like the local position. Watch the world position video to learn more about it. The difference is when we use it with skeletal meshes. For skeletal meshes, this node outputs a 3-channel vector value that gives access to the default pose position data for use in per vertex outputs. This enables us to have localized effects on an animated character. For example, add wounds on a moving character. With the pre-skin node, the material is applied before the animation, but with the local position node, the material is applied after the animation. So for animated characters, the pre-skin nodes is the way to go. If I hover the mouse on top of the node, we can see that this node too is incompatible with the GPU skin cache feature. This node returns info about the local bounding box for skeletal meshes and the regular local space bounding box for static meshes. What is a bounding box? It is an invisible box encompassing the whole mesh. We can enable the bounds from up here. Click on Show, under Advanced, enable the Bounds option. And now when I select the meshes, we can see their bounding box. This is the world space bounding box. We can see that when we rotate the mesh. Local bounding box rotates with the mesh. Let's disable it and continue with the node. This one works with both vertex shader and pixel shader, so we don't need to use the vertex interpolator node after it. It has 4 outputs. Extents gives us the width, depth and height of the local bounding box. Half extents gives us half the width, depth and height of the local bounding box. And min and max output the minimum and maximum 3D point of the local bounding box. We can use it to create localized effects like local space gradient. Add the pre-skinned position node. Connect it to the vertex interpolator. And then divide it by the extents of the pre-skinned local bounds. Mask its B channel and connect it to the base color. Apply the material and assign it to these meshes. We can rotate them and the gradient won't change. Let's add some more nodes to have more control over the gradient. Multiply it by a parameter. Name it gradient sharpness. And set the default value to 1. Then add it to another parameter. This one will be gradient offset. Set the default value to 0 and connect it to a saturate node. Connect it to the base color and save the material. And now we have control over the gradient. This is the sharpness. And with this one we can control the offset. We can move it down or move it up. Duplicate the material and open it. In this one, instead of the pre-skinned local bounds, let's use the object local bounds. Save the material. I've adjusted the gradient so the transition happens on the hip and the hands of the characters. One is using the object local bounds and one is using the pre-skinned local bounds. As you can see, when using the object local bounds, the gradient slides on the character, but with the pre-skinned node, the gradient sticks on it. As we saw in this video, in some cases, in order to use the pre-skinned nodes, we should use them with vertex interpolator. So the next video will be about the vertex interpolator node. I'll put it up here as soon as I upload it. So click here for more Unreal stuff, and thank you so much for watching. Like this video, subscribe, and join our communities on Telegram, Discord and Facebook. If you have any questions, leave them in the comment section below. So, see you in the next one.